Welcome everyone. Myself J. Rajnikant, Assistant Professor in Department of CSE, SRK Engineering College, Bhimavaram. So today we are seeing about packet switching in computer networks. So here we'll see about why there is a need of packet switching, what are the basic principles of packet switching, and what are the different types of packet switching techniques we are having, and what are the advantages of using this packet switching. Why now we'll see why there is a need of packet switching. The circuit switching telecommunication network was originally designed to handle voice traffic, and the majority of the traffic on these networks continues to be a voice. A key characteristic of circuit switching network is that resources within the network are dedicated to a particular call. For voice connections, the resulting circuit will enjoy a high percentage of utilization because most of the time one party or the other is talking. However, as the circuit switching network began to be used increasingly for data connection, two shortcomings became apparent. In typical user-host data communications, much of the time the line is idle. Thus, with the data connections, a circuit switching approach is inefficient. In circuit switching network, the connection provides for the transmission at a constant data rate. Thus, each of the two devices that are connected must transmit and receive at the same data rate as the other. This limits the utility of network in interconnecting a variety of the host computers and workstation. As circuit switching technique is inefficient for the data transmission, for effective transmission of the data, there is a need of packet switching. Now we'll see about basic operation of packet switching. To understand how the packet switching addresses these problems, let us briefly summarize packet switching operation. Data are transmitted in smaller packets. A typical upper bound on the packet length is 1000 octets, bytes. If a source has a longer messages to send, the message is broken up into series of packets. Each packet contains a portion of user data plus some control information. The control information at a minimum includes the information that the network requires to be able to route the packet through the network and deliver it to intended destination. At each node en route, the packet is received, stored briefly and passed on to the next node until it reaches the destination. So in this diagram, see here the application data is divided into small packets, 1, 2, 3 packets. So this each and every packet is having this portion. This is nothing but a control information which is used to process the packets. Now this packet switching network will route these 3 packets to the destination. So how the procedure is going to be carried out, we'll see later. Now we will see what are the advantages of packet switching. So here the first advantage is line efficiency. Line efficiency is greater because a single node to node link can be dynamically shared by many packets over time. The packets are queued up and transmitted as rapidly as possible over the link. By contrast, with circuit switching, time on a node to node link is pre-allocated using synchronous time division multiplexing. Much of the time, such a link may be idle because a portion of its time is dedicated to a connection that is idle. Next one is data rate conversion. A packet switching network can perform data rate conversion. Two stations of different data rates can exchange packets because each connects to its node as at its proper data rate. Whereas in circuit switching, they has to use the same data rate at the both ends. Next one is packets are accepted even when the network is busy. When the traffic becomes heavy on a circuit switching network, some calls are blocked. That is, network refuses to accept additional connection request until the load on the network decreases. On packet switching network, packets are still accepted, but the delivery delay increases. Next one is priorities used. Priorities can be used. If a node has a number of packets queued for transmission, it can transmit the higher priority packets first. These packets will therefore experience less delay than lower priority packets. Next one is switching technique. So what are the different switching techniques we are having? Station breaks long messages into the small packets. Packets sent one at a time to the network. So the packets are handled in two ways. One is datagram approach and another one is virtual circuit approach. Now we'll see about what is datagram mechanism. In datagram approach, each packet is treated independently with no reference to the packet that have gone before. This approach is illustrated in the following figure. Packets can take any practical route. Packets may arrive out of order. Packets may go missing, up to receiver to reorder packets and recover from missing. So in this figure, which shows a time sequence of snapshot of the progress of 3 packets through the network, each node chooses the next node on a packet's path, taking into account information received from the neighboring nodes on traffic, line failures, and so on. So the packets, each with the same destination address, do not all follow the same route, and they may arrive out of sequence at the exit point. So in this example, the exit node restores the packet to their original order before delivering them to the destination. It is the duty of the exit node to arrange the packets in order and give it to the destination. So see, in this diagram, we are dividing this packet into 3. We are dividing this data into 3 packets, 1, 2, 3. So the 3 is passing through this node and this node, and it is going to the destination by using this route. The 2 is using this route, and it reaches the destination in different route. So here there is no rule that all the packets that belongs to the same message has to choose the same series of nodes. They can use their independent nodes. The main task of this mechanism is to reach the destination. There is no rule that they have to follow the same set of nodes. In some datagram networks, it is up to the destination rather than exit node to do the reordering. Also, it is possible for a packet to be destroyed in the network. For example, if the packet switching node crashes momentarily, all of its queued packets may be lost. Again, it is up to either the exit node or the destination to detect the loss of packet and decide how to recover it. In this technique, each packet treated independently. Next, we'll see about virtual circuit path. In virtual circuit approach, a pre-planned route is established before any packets are sent. Once the route is established, all the packets between a pair of communicating parties follow the same route through the network. Because the route is fixed for the duration for a logical connection, it is somewhat similar to a circuit in circuit switching network and is referred to as virtual circuit. Each packet contains a virtual circuit identifier as well as data. Each node on the pre-established route knows where to direct such packets. No routing decisions are required. At any time, each station can have more than one virtual circuit to any other station and can have virtual circuit to more than one station. So the main characteristic of the virtual circuit technique is that a route between stations is set up prior to the data transfer. Note that this does not mean that this is a dedicated path as in circuit switching. A transmitted packet is buffered at each node and queued for output over a line, while the other packets on other virtual circuits may share the use of the line. The difference from the datagram approach is that with virtual circuits, the node need not make a routing for each packet. It is made once for all packets using that virtual circuit. If two stations wish to exchange data over an extended period of time, there are certain advantages to the virtual circuit. First, the network may provide services related to the virtual circuit, including sequencing and error control. Sequencing refers to the fact that because all packets follow the same route, they arrive in original order. Error control is a service that assures not only that packet arrive in proper sequence, but also that all packets arrive correctly. For example, if a packet in a sequence from node 4 to node 6 fails to arrive at the node 6 or arrives with an error, node 6 can request a retransmission of that packet from node 4. Another advantage is that packets should transmit the network more rapidly with a virtual circuit. It is not necessary to make a routing decision for each packet at each node. So see in this diagram, the message is divided into small chunks, that is 3 packets as in datagram approach, but by using this series of nodes, a route has been established between source and destination. So all these 3 packets are going to be transmitted by using this series of nodes only, whereas in datagram approach, each and every packet is having its own node and it passes on the series of nodes and it will reach the destination by its by selecting its own nodes. But here a dedicated route is established between source and destination. That route is not like a path, dedicated path that is established in circuit switching technique. So now we'll see the major differences between virtual circuit and datagram. So in virtual circuit approach, the network will itself will provide some sequencing and error control mechanisms. Here packets are forwarded more quickly because no decisions for routing are made at each and every node. A route is established between source and destination. There is no need of having routing decisions at each and every node. So if there is a loss of a single node, all the circuits through that node will be spoiled. So that is less reliable if any node loses. Next one is in datagram approach, no call setup is required for the transfer of data. Next, routing can be used to avoid congestion parts of the network. If the particular route is having if particular node is having congestion, it will abolish sending the packets through that particular node. So that is the advantage of. So next we'll see about packets. Next we'll see about packet size. There is a significant relationship between packet size and transmission time, as shown in the figure. In this example, it is assumed that there is a virtual circuit from station X through nodes A and B to station Y. The message to be sent comprises 40 octets and each packet contains 3 octets of control information, which is placed at the beginning of each packet and is referred to as header. If the entire message is sent as a single packet of 43 octets, then the packet is first transmitted from station X to node A. When the entire packet is received, it can be transmitted from A to B. When the entire packet is received at node B, it is then transferred to station Y. Suppose that now that we break the message into 2 packets, each containing 20 octets of message and of course 3 octets of header information or control information. In this case, node A can begin transmitting the first packet as soon as it has arrived from X without waiting for the second packet. Because of the overlap in transmission, the total transmission time drops to 92 octet times. By breaking the message up into 5 packets, each intermediate node can begin transmission even sooner and the savings in time is greater with a total of 77 octet times for transmission. However, this process of using more and smaller packets eventually results in increased rather than reduced delay, as illustrated in this figure D. See here, if you are using 5 packet messages, the transmission time is lesser than 2 packet messages. But if you are using 10 packet messages, it is greater than 5 packet messages, because if you are dividing the packets into more numbers, a header will be increased, so that the data overhead also will be increased, so that there will be increase in transmission time also. Now we'll see some comparison between circuit and packet switching. So for that, first we have to see about 3 important factors, that is propagation delay, transmission time and node delay. So the time it takes to signal to propagate from one node to the next, this time is generally negligible. That is nothing but propagational delay. Transmission time, the time it takes for a transmitter to send out a block of data. For example, it takes 1 second to transmit a 10,000 bit block of data onto 10 kbps line. Node delay, the time it takes for a node to perform the necessary processing as it switches data. Now we'll see event timing for circuit switching, virtual circuit packet switching and datagram approach. So in circuit switching approach, see that for call establishment, there will be handshaking between sender and the receiver. So while establishing the call, there is some propagation delay, and there is no propagation delay while transferring the data. In virtual circuit approach, while establishing the call, there is some propagation delay. So in packet transmission also there is some propagation delay, and while releasing the connection also there is some propagation delay. Whereas in datagram packet switching approach, there is propagation delay only in transfer of packets, because there is no need of any call establishment here. Thank you.